Alright, let's go. Chapter 1, Day 3 notes. We're going to talk about some matrix operations. Today we're just going to talk about a couple. Multiplication is a whole nother day all in itself. So we're going to start with addition and subtraction. One thing you need to know for addition and subtraction is that the matrices must be the exact same size for you to be able to add or subtract them. If they are the exact same size, then all you have to do is, add or subtract the numbers that are in the corresponding places. So for the first example, we have a 2 by 2 matrix here, we have a 2 by 2 here, so they are the exact same size. So that we would just add our top left and top left, so 2 plus 6 is going to give us 8. And 4 plus 1 is 5. 3 plus a negative 4 is a negative 1. And negative 5 plus 5 is 0. And you will end up with a 2 by 2 matrix because they must be the exact same size. To add or subtract them, they will end up with the exact same size. For the second example, we have a 2 by 2 and a 2 by 1. Since they're not the same size, you cannot even answer this question. They cannot be subtracted. So the next example, again, this is just a little bit bigger. You want to be really careful when you're subtracting because remember, when you are subtracting, if you subtract a negative, you actually need to add those two together. So 2 minus 2 is 0. 1 minus a negative 1 is 2. Negative 4 minus 3 is a negative 7. 6 minus a negative 4 is 10. 0 minus 3 is a negative 3, and a negative 2 minus 1 is a negative 3. Next example, go ahead, try it really quick on your own. I'm sure you'll come up with the correct answer. Two plus 6 minus a negative 3 is giving you 11. And 1 plus a negative 2 minus 4 is a negative 5. Okay, so pretty simple. Just basically adding and subtracting. Just make sure you're doing it with the correct numbers based on their location. Scaling. That's basically a fancy name for matrix distributing. Just the other day we learned or refreshed our memory how to distribute. Basically what you're going to do is you're going to multiply this 3 into everything inside this matrix. So, like I said, it's kind of like matrix distributing. 3 times 6 is 18, 3 times 1 is 3, 3 times 0 is 0, and 3 times a negative 2 is a negative 6. So why don't you go right ahead and try the next two examples really quick. Go ahead and pause the video, try them on your own. And here we go. Negative 2 times 6 is going to give you your negative 12. Negative 2 times a negative 11 is 22. Negative 2 times 0 is 0. And you're done with that one. And same thing, even if there's variables, no worries, you're just going to distribute. 4 times 2x is 8x. 4 times 1 is 4. 4 times 3 is 12. 4 times a negative y is a negative 4y. And the last example, basically it's a combination of adding or subtracting, depending on how you do this question, and some scaling. So the first thing, I'm going to show you a little trick to get rid of a minus. If you don't like subtracting a whole matrix from another one, you could actually change it to addition. In this case, what we're going to do is this first one we're just going to scale by 3. 3 times 2 is 6. We got our 18, negative 3, and 12. But instead of just distributing the 2 into the second matrix, we're going to distribute the entire negative 2, which will turn this into a plus sign. So we're going to have a negative 10, 0, negative 2 times a negative 4 is a positive 8, and negative 2 times 3 is a negative 6. So what that does is, in one of the earlier examples, when you subtract a negative, you have to remember to change that into addition. If you get rid of that by distributing the entire negative sign to every term inside the matrix, then you're just adding. So 6 plus a negative 10 is going to give you your negative 4. 18 plus 8 is going to give you 26. Negative 3 plus 0 is negative 3. And 12 plus a negative 6 is just going to be 6. Go ahead and pause for a moment, and we will see you in just a minute. Okay, so we have solving for variables. Basically what we're going to do here is we are just going to take an equation of matrices and we're just going to turn it into regular old school solving for a variable based on the location of each term. So for the first example we have to solve for x and y, but we're just going to take our x's at the top, so we're just going to create an equation. So we're going to have 2x plus a negative 4 is equal to 6, and we just solve it. This is like 2x minus 4 is equal to 6. Add 4 to both sides. 2x equals 10. So x equals 5. And we do the exact same thing with our y placement, which is at the bottom. 3 plus y is equal to a negative 2. Subtract 3 from both sides. We get y equals a negative 5. Okay, so go ahead and pause again. See if you can try that bad boy at the end on your own. And try to solve for x and y. That'll complete these notes. After you're done with that, like I said, pause it, give it a try on your own. Okay, here we go. We're solving for x, but we have a scalar, so we need top left is equal to top left. So this is going to be 3x minus 8 is equal to 4, because we have to scale the first and second matrix by, we got 3 and we have a negative 4. So that's just going to give us 3x is equal to 12, and then we're going to divide by 3 and we get x equals 4. And then we got to do the same thing with y. Y is in the bottom right this time, so all of our bottom rights. Distribute the 3, so we're going to have 12 minus 8y is equal to a negative 4. Subtract 12 from both sides. We're going to have negative 8y is equal to a negative 16. So y equals a positive 2. Alright, that takes us to the end of day 3 notes. Hope everything is clear and you understand everything. If not, remember, you can come ask me questions tomorrow. Have a good one.